Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss statistics. In the previous class, we have discussed how to arrange the given data in the tabular form. Yes or no, my children? The tabular representation of data is very useful in summarizing the raw data and presenting them in a systematic manner. Oh, yes or no, my children? Right. But the tabular representation of the data do not always prove to be very interesting to the common man. One of the most appealing and convincing ways of presenting the data is through pictures and graphs, because graphs or pictures, if drawn attractively, they are eye catching and make unwieldy data easily intelligible. Moreover, graphs are very good visual aids. There are various methods of graphical representation of frequency distribution. In this exercise, we are discussing graphical representation of data. Okay, my children. I hope you have understood the previous exercise concepts, and I hope you have learnt the sums related to that concepts, and I hope you have completed exercise 14.2. All the sums were finished. Yes or no, my children? Right. Now see the first point, graphical representation of data. Okay, my children, we shall study the following graphical representations in this section. They are bar graphs. Second one, histograms of uniform width and varying widths. And the third one is frequency polygon. Okay, my children, we use these three ways to represent the given frequency distribution table graphically. Okay, my children, right. See the first one, bar graph. You know well about bar graph. In earlier class, we have already studied. You have drawn bar graphs, haven't you, my children? Right. A bar graph is a pictorial representation of data in which usually bars of uniform width are drawn with equal spacing between them on one axis, say the x-axis, depicting the variable. The values of the variable are shown on the other axis, say the y-axis, and the heights of the bars depend on the values of the variable. Okay, my children, do you remember these points while you are drawing bar graphs of a frequency distribution table? Right. Now come to the next point. While constructing bar graphs, the following points should be kept in mind. Okay, my children, while you are drawing the bar graphs for the given data, please keep these points in your mind. First point, the width of the bars should be uniform throughout. Okay, my children, this is the first point you should remember. Width of the bars should be uniform. And second one, the gap between one bar and another should be uniform throughout. There should be uniform gap between bars. Okay, my children. And the third one, bars may be either horizontal or vertical. The vertical bars should be preferred because they give a better look. Okay, my children, understood these points? Please remember these 3 points while you are constructing a bar graph for the given data. Okay, my children, right. To understand this concept well, let us take an example. Okay, my children, how to represent the given data by a bar graph. Right. The following table gives the number of vehicles passing through a busy crossing in Delhi in different time intervals on a particular day. A data is given in the form of a table, tabular form. Time interval in this column, number of vehicles. 8 to 9 hours 300, 9 to 10 hours 400, 10 to 11 hours 350, 11 to 12 hours 250, 12 to 13 hours 200, 13 to 14 hours 150, 14 to 15 hours 100. Like this, a data is given in the tabular form. We have to represent this data in a bar graph. Okay, my children. Right. So you have to use graph paper, graph sheet. In a graph book, you have to solve this question in the graph book only. Okay, my children. Right. On x-axis, let us take on x-axis. Here y dash. Here x dash x. Here origin. O is the origin. Point of intersection of these two axes. X axis and y axis. We have studied the coordinate system. Yes or no, my children? Right. So on this x axis we are taking time interval. Here time interval. What are the time intervals? 9 to 8 to 9. 8 to 9. Next 9 to 10. Next 10 to 11. Next 11 to 12. Next 12 to 13. Next 13 to 14. Next 14 to 15. Like this we have taken these values time interval on x-axis. On y-axis we are taking number of vehicles. Number of vehicles. Here we are taking scale. On this y-axis 1 centimeter is equal to 50 vehicles. Okay, my children. Scale. We have to take scale. On y-axis. On y-axis 1 centimeter is equal to, as per our convenient, we have to choose the scale. Okay, my children, I have chosen on y-axis 1 centimeter is equal to 50 vehicles. So here we take here 50, here 100, here 150, here 200, here 250, here 300, here 350, here 400. Like this we have to take a scale, a suitable scale, convenient scale on y-axis. Understood this point, my children? Right. See this first one, 8 to 9 hours. How many vehicles? 300. So we have to draw a bar. With uniform width, we have to draw the bars. 9 to 10 hours, 400. So here, by giving a suitable gap, 400. Okay, my children. Next, 10 to 11, 350. Here 350 is there. Okay, my children. Similarly here 11 to 12. Uniform gap. 11 to 12. 250. Here 250. We should give uniform gap with each and every bar. One bar to another bar. We should give equal gap. Okay, my children. For example, take 1 centimeter between each and every bar. Similarly here 12 to 13. 12 to 13. 12 to 13. 200. 200. Next 13 to 14. 13 to 14. 150. So 150. Okay, my children, understood this point. Next 13 to 14 to 15. 100. This is the graphical representation of this data by a bar graph. Understood this point, my children? You can write here also 300. You can write here number clearly 400. Here 350. Here 250. Here 200. Here 150. Here 100. Okay, my children, understood? Right. In the exercise 14.3, the first three sums are based on bar graphs. Okay, my children, please try the first three sums in the exercise 14.3 by yourself. If you have any doubts, ask your doubts and get your doubts clarified by observing the solution of this example. Please try the first three questions in the exercise 14.3. Okay, my children, will you do it, my children? Right. Now come to the next point, that is histogram. This is also another pictorial representation of the given data. A histogram is a graphical representation of a frequency distribution in the form of rectangles with class intervals as bases and heights proportional to corresponding frequencies, such that there is no gap between any two successive rectangles. Okay, my children, in bar graph there is a gap, uniform gap between rectangles, whereas in the case of histogram there is no gap between any two successive rectangles. Please remember this point. This is a major difference between bar graphs and histogram. Okay, my children, a histogram is a two-dimensional diagram. We shall discuss the construction of a histogram for the following frequency distribution separately. Here 4 types of frequency distribution will be given. For each and every type of frequency distribution table, we have to draw histogram. First type of frequency distribution table, a continuous grouped frequency distribution with equal class intervals. Okay, my children, this is the first type of frequency distribution table. Continuous. I will explain you what is meant by continuous. Next, second point, a continuous grouped frequency distribution with unequal class intervals. Okay, my children, understood this point. Here class intervals are same. Here different class intervals, different widths. Okay, my children. Next, third point, a frequency distribution in which midpoints of class intervals are given. In this case, we have to draw a histogram. And the next fourth type, a grouped frequency distribution in which class intervals are given in inclusive form. Okay, my children, I will explain you what is meant by class intervals are given in inclusive form. Okay, my children, right. Now come to the next point, fifth point, construction of a histogram of a continuous grouped frequency distribution. In this point, we are discussing how to construct a histogram of a continuous grouped frequency distribution. Okay, my children, right. Please listen carefully and remember these steps in drawing the histogram of the above frequency distribution, we use the following algorithm. Here we use these five steps in drawing the histogram of a continuous grouped frequency distribution. Okay, my children. Right. Step 1. Take a graph paper and draw two perpendicular lines, one horizontal and one vertical, intersecting at O. Say origin O. Mark them as OX and OY. Please recall the previous knowledge of coordinate system. On the graph paper, draw the x-axis and y-axis. They intersecting at O, origin. Okay, my children. Right. Step 2. Take horizontal line OX as x-axis and vertical line OY as y-axis. This is also, we have learnt this point also in the coordinate system. Haven't you, my children? Right. Step 3. Choose a suitable scale and along x-axis represent class intervals. You have to choose a suitable scale on the x-axis and we have to represent class intervals on x-axis, along the x-axis. Okay, my children? Right. Now come to the step 4. Choose a suitable scale for y-axis and mark frequencies along y-axis. Okay, my children? Right. Step 5. Construct rectangles with class intervals as bases and respective frequencies as heights. Okay, my children? Right. Note. It should be noted that the scale for x-axis may not be same as the scale for y-axis. Okay, my children, they may not be same. You should remember all these 5 points, 5 steps, all these 5 steps in constructing a histogram of a continuous grouped frequency distribution. Okay, my children, right. To understand this point well, let us take an example. Draw a histogram of the following frequency distribution. Okay, my children. Marks in an exam. Here, number of students 30.5 to 35.5. 9 students are there. 35.5 to 40.5. 6 students are there. 40.5 to 45.5. 15 students are there. 45.5 to 50.5, 3 students are there. 50.5 to 55.5, only 1 student. 55.5 to 60.5, 2 students are there. Okay, my children, this is a given frequency distribution table. This is a grouped, this is called grouped distribution table. How do you say? Yes, class intervals. These are class intervals. These are frequencies. Class intervals and frequencies are given. So we can say that this distribution table is a grouped frequency distribution table. Okay, my children. Now, how can you say it is a continuous frequency distribution table? Yes, a question arises in your mind. How to find, how to check, how to verify the given distribution, frequency distribution is a continuous frequency distribution, right? See here, This is called lower limit, this is called upper limit. You know this point. In the previous class we have discussed this is the lower limit, this is upper limit. If you observe, this upper limit is equal to the lower limit of the next class interval. Yes or no, my children? Similarly, this upper limit is equal to the lower limit. The lower limit of the next class equal to the upper limit of the previous class. See here, lower limit of this class interval is equal to the upper limit of the previous class interval. Yes or no, my children? Similarly, the lower limit of this class interval is equal to the upper limit of the previous class interval. Yes or no, my children? If you observe all these class intervals, the same rule is applied. Yes or no, my children? So, if these two numbers are equal, these limits are equal like this, then this grouped frequency distribution table is said to be continuous frequency distribution table. Okay, my children, understood this point? How to identify, how to examine the given distribution table is a continuous frequency distribution table or not, right? So this is a grouped continuous frequency distribution table. So to draw the histogram of this grouped frequency distribution, you know, you have to draw horizontal line and vertical lines in the graph sheet only. Okay, my children, you should use a graph sheet only to draw histogram, to draw bar graph. Okay, my children. So x dash, here x, here y, here y dash. They are intersecting at point O, origin. Okay, my children. See the, after taking the horizontal and vertical lines we have drawn coordinate axis, we have to choose a scale on x-axis. On x-axis 10 marks, 1 centimeter is equal to 10 marks. 1 centimeter is equal to 10 marks. Okay, my children. Sorry, 5 marks. 1 centimeter is equal to 5 marks. Similarly, on y-axis, observe these frequencies 9, 6, 15, 3, 1, 2. Okay, my children. Let us take 1 centimeter is equal to 2 students. 1 centimeter is equal to 2 students. On y-axis, 1 centimeter is equal to 2 students. Okay, my children. So here, and moreover here, it is not starting from 0. The first class interval is not starting from 0, but here is origin. So we have to draw a break, a kink like this. Just we have to cut that point like this, a short break. Now here we have to take 30.5, here 30.5, 35.5, next to 40.5, next to 45.5, next to 50.5, next to 55.5, next to 60.5. 1 centimeter is equal to 5 marks. Okay, my children, marks. On x-axis, we have taken marks in an exam. On y-axis, we are taking number of students. Number of students. And what is the scale here? 1 centimeter is equal to students. So here 2, 4, 6, 8, 10, 12, 14, 16, 18. I have taken like this on y-axis. Understood this point, my children? Right. See here 30.5 to 35.5. How many students are there? 9 students. So you have to draw a rectangle. Okay, my children? 9 students. So here 9 between 8 and 10. Okay, my children. So 9 students. Here 9 students. Next to 35.5 to 40.5. How many students are there? 6. 35.5 to 40.5. How many? 6 students. Understood this point, my children? Right. Next to 15 students. 40.5 to 45.5. 15 students. So it lies between 14 and 16. Just midpoint. Understood this bar, my dear children? Understood this rectangle? Right. Next to 45.5 to 50.5. Only 3 students. 45.5 to 50.5. Only 3. So it lies between 2 and 4. It is a midpoint. Just middle. 3 students. Understood this rectangle, my dear children? Right. Next, 50.5 to 55.5, only 1 student. 50.5 to 55.5, only 1 student. So between 0 and 2, middle. You have to take middle. Only 1 student. Understood this rectangle, my dear children? Similarly, last class interval, 55.5 to 60.5. 60.5. How many students are there? 2 students. This is the histogram of the given grouped frequency distribution. Understood, my dear children? Right. Now come to the next point. That is sixth point. Construction of histogram when cross intervals are given in inclusive form. That is, class intervals are not continuous. Okay, my dear children. In this point, we are discussing how to draw, how to construct a histogram of frequency distribution which is not continuous. Okay, my dear children? Right. If the given grouped frequency distribution is not continuous, we first convert it into a continuous frequency distribution by using the following procedure. Okay, my dear children, first of all, we have to convert the given frequency distribution which is not continuous into a continuous frequency distribution. To convert a given frequency distribution into a continuous frequency distribution, we follow the steps given below. Okay, my children, we follow these 2 steps to convert the given frequency distribution which is not continuous into a continuous frequency distribution. First step, compute the difference between the lower limit of the second class interval and upper limit of the first class interval. Let the difference be h. Okay, my children, first of all, we have to find the difference between the lower limit of the second class interval and upper limit of the first class interval. Second step, subtract h by 2 from the lower limits of each class and add h by 2 to the upper limits of the each class. Okay, my children, understood this point? After converting the given class intervals into continuous intervals, we draw the histogram with reference to continuous class intervals. Understood this point, my dear children? Right. To understand this point well, let us take an example. Okay, my dear children. The following table represents the number of illiterate females in the age group 10 to 34 in a town. Okay, my children, this is a frequency distribution. Age group 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34. Number of females here 300, 980, 800, 580, 290. Draw a histogram to represent the above data. Okay, my children, right. If you observe this frequency distribution table, it is not a continuous frequency distribution table, because here upper limit of the first class is not equal to the lower limit of the second class. Similarly here upper limit of the second class is not equal to the lower limit of the third class. Similarly, upper limit of the third class is not equal to the lower limit of the fourth class interval, and so on. As are mentioned, they are not equal. So this is not a continuous frequency distribution table. So first of all, we had to make this frequency distribution table as a continuous frequency distribution table. Okay, my children, right. The given frequency distribution is not continuous. It is not continuous. So first of all, we have to convert into continuous. We convert it into a continuous frequency distribution. Then what are the steps to be followed to make this frequency distribution into a continuous frequency distribution? Yes, take the difference between the upper limit and lower limit of the upper limit of the first class interval and lower limit of the second class interval. Difference between the upper limit of the first class and the lower limit of the second class. Okay, my children, that is H. Let us consider this is H. So H is equal to, say H. Let us consider the difference between the upper limit of the first class and the lower limit of the second class. That is equal to H. So what is H here? (15 minus 14). That is 1. Yes or no, my children? Right. After that, we have to find H by 2. That is 1 by 2. That is equal to 0.5. So, from lower limits of the each class, we have to subtract 0.5 and we have to add 0.5 to upper limit of the each class. Okay, my children. Now, modified frequency distribution. Age group, here. Next, number of females. Here 10 is there, we have to subtract 0.5. Then what you get? 9.5. Here we have to add 0.5 to 14. So we get to 14.5. Understood this class interval, my children? Right, 300. Next, here 14.5. From this number we have to subtract 0.5. Then we get 14.5. Here we have to add 0.5. Then we get 19.5. Here this is 980. Understood this second class interval, my children? Similarly, here 19.5. Here 24.5. 800. Next 24.5. 29.5. 580. 29.5. 34.5. 290. Now, if you observe this frequency distribution, it is a continuous frequency distribution because the lower limit of the second class is equal to the upper limit of the first class. The lower limit of the third class interval is equal to the upper limit of the second class interval. Similarly, the lower limit of the fourth class interval is equal to the upper limit of the third class interval. Similarly, the lower limit of the fifth class interval is equal to the upper limit of the fourth class interval. Understood this point, my children? Therefore, this is called continuous frequency distribution. Now, you know that how to draw the histogram of a continuous frequency distribution. Okay, my children, we follow the steps as we have done to draw a histogram of a continuous frequency distribution. Okay, my children, right. Now observe this frequency distribution. This is a continuous frequency distribution. Okay, my children. Now let us draw histogram for this frequency distribution on graph sheet only. Okay, my children, please remember this point. On graph sheet only, not on your classwork notebook. Please remember this point, my children. So first of all, we have to draw coordinate axis on the graph sheet. Okay, my children, right. On x-axis, let us take age group. Age group. On y-axis, number of females. Number of females. Okay, my children. After taking these points, we have to choose a suitable scale on both axes. Don't forget, my children, this is also important point when you are drawing histogram of a frequency distribution. On x-axis, 1 centimeter is equal to, I will take 4 years. 1 centimeter is equal to 4 years. On x-axis, I am taking 1 centimeter is equal to 4 years. And on y-axis, this is on x-axis. Next on y-axis, on y-axis 1 centimeter is equal to 100 females. Okay, my children. I'm taking like this on the y-axis. Scale on y-axis. Okay, my children. Right. Now here, if you observe the first class, it is starting from 9.5, not from 0. Okay, my children. As we have done, we have to draw a break, a short break, like this, a short break. And we start here, from here, 9.5, 9.5, next to 14.5, next to 19.5, next to 24.5, next to 29.5, next to 34.5. Okay, my children, understood these numbers on x-axis. On y-axis, I have taken 1 centimeter is equal to 100 females. Okay, my children. So here 100, here 200, here 300, 400, 500, 600, like this. Okay, my children. Right. Now, first class 9.5 to 14.5. How many females? 300 females. So, we have to draw a rectangle. 300. Understood this rectangle, my children? For the first class, we have drawn a rectangle. Now let us take the second class, 14.5 to 19.5. How many is two females? 980. Okay, my children, here 700, here 800, here 900, here 1000. Okay, my children. So, this is 980. 980 females. Understood this is second rectangle, my children? Right. Similarly, we draw rectangle for the third class. 19.5 to 24.5. How many females? 800. Okay, my children. So here 800. 800. Understood this third rectangle, my children? Right. Now come to the fourth rectangle. 24.5 to 29.5. How many females? 580. So between 500 and 600. 5.8. Take 5 scale. Okay, my children. 580. Understood this rectangle, my children? Right. Next, last class. 29.5 to 34.5. How many females? 290. So it lies between 200 and 300. It is nearest to 300. 2.9. 2.9 centimeters on y-axis. Okay, my children? Right. 290. Understood this rectangle, my children? Right. This is the histogram of the given frequency distribution. Understood, my children? Right.